if the values of two variables are the same, you can use this equal operator. That is not equal, it's assignment. It doesn't return anything. This statement returns a true or false. So if the value of A and B are the same, the result of this operator is true. Otherwise, it's false. Then we have the greater operator, greater or equal, less than or equal, and this is not equal. Equal, not equal. So if A and B are not the same, their values are not the same, then it's true. Otherwise, it's false. But don't forget, all of these operators, they return true or false. Okay? And if you look at the keyboard, we don't have this character. So we show it like this. We don't have this character. We show it. But the meaning is exactly the same as what we use in math. Any question? This is a simple example. We have a variable declaration and initialization here, n of type integer, and it's assigned by 5, and it's assigned by 6 at the same time. Then we define a Boolean variable. To refresh your memory, a Boolean variable can only hold true or false. And then we assigned it by the result of this operation. This is a logical operation. When we say logical, it means it always returns true or false. So, m, Boolean be assigned by m greater than n. We perform, actually the compiler performs the operation and returns the result and saves the result into b. So m is 5, n is 6. 5 is not greater than 6. The result is
false.
False. So the value of b will be false, because this statement is false. Okay? That's a simple example. Any question? Moving on. Suppose we have these variable declaration and initializations, and we have these Boolean expressions, and these are the results. For example, money equals 100. Money is decimal. We cannot compare a decimal with other data types, because it's not exactly a simple numeric variable, and it wasn't in that table, in that number data type table. We have wide, we have long, we have short sign and long sign of both of them, integer, double and float, but not money. So when we want to perform comparison between data types that cannot be logically be compared, you get an error, type mismatch error. So here, money is decimal, and we can't compare it with a number because of these additional character that they have here. So we get type mismatch. But for example here, money is equals to 15.22 million. The same value, same data type. So the result is true. Here, A value is greater than B value. A value and B value both are integer, so the data type are the same. We can perform comparison. A value is 100, B value is 1000. 100 is not greater than 1000, so the result is false.
There isn't. What is value type decimal supposed to be?
It's a number,
Uh-huh.
and following up about some other characters that have specific meanings. We usually use them with money and those sort of stuff. But you don't have to use it. You can use a double, because if you want to see it as a number, you have to convert it to a number. And here, C value less than character F. So since we are comparing with character, C value must be of character data type. And C value is a character, and its value is the character A. So we have the character A capital less than character F lowercase. If you remember, characters are saved as their ASCII code or Unicode. So the Unicode of character A is 65. The Unicode of character F is 102. 65 is less than 102, so the result is true. Now you tell me why we get syntax error in this one.
Because it hasn't got an equals.
I'm masking the answer.
Because it's only saying equals, it's no greater than or.
Thank you very much. Absolutely correct. This is assignment, not equal.
I still don't really understand what you mean by, like, assigned by.
Equal returns a true or false.
Yeah.
If two variables hold the same data value, then the result of equal is true, otherwise is false. Assignment is copying. It means copy the value of B into A. That's assignments. This is equal.
So
this is assignment. So you get error here,
So
because it's not a Boolean expression.
So if you didn't put the F as a character, would it convert it into
It
the...
doesn't matter. It doesn't go there. We are using the incorrect operator here. We are checking equality, but we are using assignment operator. We are using incorrect operator.
So it has to be an
this
equals.
is an error, regardless of the data type. We don't get there. So don't be confused between assignment and equal. Different operators. This is a logical operator. It returns a true or false. That is copying value of the right side into the variable that is on the left side. Clear? And then the next type of logical operators, compound logical operators. Not and, or, and XOR. Let me give you an example. We don't have an equal operator of these compound logical operators in math, but we have them in daily English that we use. For example, if I am a lecturer at MIT and I am a male, being a lecturer and a male actually lecturer, then do something. So we are checking two conditions. The first condition, Reza is a lecturer at MIT. The second condition, Reza is a male lecturer. And we use and in the between. we use and every day and in our actually conversations. They have exactly the same meaning in programming languages. And or. So, let's get to it. This is not A. First of all, every compound logical operators must be applied to binary variables or any Boolean expression that returns true and false. Everything that goes after and before any logical operator must be of type Boolean. It has to be true, false. So, not A and B bitwise operator is not logical. A or B bitwise or A X or B, A and B logical, A or B logical. Let's see what this means. When we explain logical operators, we use a table which is called a truth table. So we say if the value of A is true, then not A is false. If value of A is false, not A is true. So not is a unary operator. It only has one operand. When it comes before any Boolean expression or any Boolean variable, it makes it inverse. If it's true, the result is false. If it's false, the result is
True.
Question? The truth table of logical AND. We are using 2 ampersands here. This is the AND in English. AND is true. The result of AND operator is true if all the operands are true. AND applies if all the conditions apply. So, if either of A or B are false, the result is false. The only way that the result of A and B is true is when both A and B are true. On the other hand, or, I'm using these 2 lines. There they are shift backslash on your keyboards. 2 of them, without any space between them. This is logical or. Logical or is true when either A or B are true. So, if either of A and B, A or B are true, the result is true. Otherwise, false. Exactly the way that we use it in English. If I have $5 million in cash or 10 houses, then I am rich. So either of those conditions that are applied, then I'm considered to be rich, without which I'm not. So in my case, this is here.
Bye, folks.
A or B? You're A or B.
We use and or a lot because there are so many situations in programming language that we need to make a decision, and that decision uses these operators. So for now, just understand, memorize these truth tables and this and or. And again, A and B must be of type Boolean, or any expression that returns true or false. So for example, if A and B are of type string, they hold to, for example, student names, there is no point, it's not logical to have to apply and or because it's meaningless. You get immediate error in programming. They have to be logical or Boolean. Anything that is true or false. Then we have XOR. XOR is true when A and B are not the same. One of them must be false, the other one must be true. Then XOR is true, otherwise it's false. So when the value of A and B are the same, doesn't matter false or true. That's the same, the result of A XOR B is false. Otherwise, it's true.
Thanks.
Why is it just one? Why do you call that symbol instead of two? Don't know, just because.
It's defined like that. Probably it was enough. Well, the reason that we have two of these symbols to define logical OR is because we have another meaning for one of this,
Yeah.
which we'll get into right now. But for XOR, we don't. So, let's see this example. These are just dummy code. They are not executable. So that's the dummy code. So we have exam score integer assigned by 75, homework grade integer assigned by 100, amount out double assigned by 0, and a status a character assigned by capital I. Then we have these statements. We have a Boolean expression. We call it a Boolean expression or Boolean statement or a condition. Why? Because it returns true or false. The result of this Boolean expression is either true or false. So we can use it with and or. And the same goes here. So let's see. We have exam score greater than 90 and homework greater than 80. What is the value of exam score? 75. 75 is not greater than 90. So the result of this statement is
False.
False. False and anything is
False.
false. False and anything is false. So we don't even need to check the second condition. But if you want to do it, homework grade is 100. 100 is greater than 80.
False.
True. So we have false and true, which is the result is false.
Oh, yeah.
Clear?
Yeah.
Not yet. Let's do the second one. Amount owned is, equals 0. Amount owned 0. 0 equals 0.
True.
True.
The value of amount owned is 0. So we have 0 equals 0. True. Here, a status equals capital character A. A status is I. The value of a status is I. I is not equal to character A. So, false. We have true or false.
True.
True. True or anything is true. We get back to this table. True, 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 or anything, true. You need to memorize these true tables. Oh, it's easy. It's just exactly as we use and or in English. When you use and, everything, every condition that you use to define the and must be true. When you use or, either of them is true is enough. Any question?
Will there be a hierarchy similar to the mathematical operation?
Oh, we don't have this and or in math.
I
We
mean,
use it in
which do we do first? The and
well, we need to perform the result of this one and then this one. Maybe there are more and more conditional statement. We have to get answer of all of them and then calculate the result.
Such as they can.
with
Well,
the,
no, if you mean those
Like there are multiple
operator
operations.
order applies here, no. No,
left
it
to
doesn't.
right or
No.
and
It
first or
doesn't matter.
first?
If you can start from left and go and each time. For example, if you have A, suppose A is one of those actually condition. A and B and C or D. What is 52? What we do, we calculate the first A and B, the result and C, the result of this is true or false. The result of this is true and false. And the result of overall or D. And actually it doesn't matter which way you go, the result is the same. It's not the same as arithmetic operator, priority or order. Any way that you run it, the result is the same. Any question? What you need to know is how to explain, how to describe those conditions that you want as programming language. But before we get to that one, what is binary and or and XOR? For those, these are logical operators. It means both operands must be Boolean, true or false. But for binary operators, we can apply them. We can apply and or XOR on numbers too. What is do that when we say, for example, 6 binary and 3, it uses the binary code of 6 and 3 and then perform AND bit by bit. For example, we have 6 binary and, it's not 8, it's binary and. Binary and 3, it's not logical and. Logical and is 2 of this ampersand operator. This binary and. So, when we have this operator, this statement, 6 goes to binary code, 3 goes to binary code, and then we perform bitwise and. 0 is false, 1 is true. Always. 0 is false, 1 is true. So we have 0 and 0. False and false. The result is
True.
0
False.
and
False.
0. False and false.
Equals false.
False. False is 0. 1 and 0.
False.
True and false. The result is
True.
False.
True.
true and false. The result is false.
False, yeah.
The only way and returns true or 1 is when both operators are true or
Oh,
1.
okay.
Okay? So, true or 1 and 0
false.
So it's false.
Zero.
false. The result is
False.
false. False is 0 in binary. Then we have
True.
1 and 1, or
True.
true and
True.
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 So it's true.
Right.
True. And also we have false
And
and true,
So it's false.
which is
False.
false. So the result is binary code 0010, which is number 2.
Alright.
So this is bitwise operator. You don't need it.
So Reza, how did you get that 0110 from?
That's the binary code of 6.
Do
I'm
we have
not teaching you how to convert integer to binary. That's another topic.
That's right.
We
he said
need
we
a
don't
complete paper to discuss about this binary stuff. So we don't need it, but just don't forget this operator is not the same as this operator.
Why would you want to do that kind of thing?
Come again?
Why would you want to do the binary?
Well, first of all, if you are doing if you are coding system programs, system level program, like for example compilers, operating system, there are lots of things that you need to work with, to do with bits. Then they become handy. And sometimes some programmers use this and or stuff instead of, for example, simple arithmetic operators. Why? They probably want to say that we know better than everybody. I don't know. You need to ask them. Well, I've been coding for more than a decade, and I've never used any of this so far. But I use these logical operators basically every day. So I just put this slide for you to know that we have binary AND, binary OR, and logical AND and OR, and they are different. That's all. If you're not interested, ignore this slide. So, now let's do some exercise. We have these statements in English. We want to write them as programming language, as C#. I do the first one, you do the rest. A student's name equals John.